In this question, we have two people who are separated by 50 feet apart. So at the beginning, the two persons are located at this point. One of the person is located at this point and the other person is located at this point, and they are separated by 50 feet. And this person starts walking towards north direction such that the angle between the person and the another person is changing at a rate of 0.01 radians per minute. So in such a case, we have to determine what is the rate of change of distance between these two persons. So basically we have to find dx by dt using the given information. We are also given that at that point the value of angle theta equals zero point 0.5 radians. So let's start doing this. First, let's write down the trigonometric relation, that is cos theta equals adjacent side. So if you consider this as the theta, the adjacent side to theta is this 50 feet. So I can put 50 divided by x. And from this, I can determine the value of x. So therefore, x equal to 50 divided by cos of theta. Since the value of theta is given, we can substitute here. So therefore, this becomes 50 divided by cos of 0.5. So this is basically the value of x. So let's have it like this. Now let's consider the same equation and we are going to differentiate both sides with respect to time. So let me copy this one more time. So this is equal to cos theta equal to 50 over x. Now I differentiate both sides with respect to time, and when I do that I'll be getting differentiation of cos theta is negative sine theta, and then we have to apply the chain rule to differentiate theta with respect to t. So therefore this becomes d theta divided by dt equals, this 50 is a constant and we have to differentiate 1 by x. So 1 by x can be considered as x power minus 1. So when we apply the power rule of differentiation, we get negative 1 x raised to the power of negative 1 negative 1. So this is equal to negative 1 x raised to the power of negative 2. So this is simply equal to 1 minus 1 by x squared. So I have minus 1 by x squared, and then I have to apply the chain rule to differentiate the x with respect to t. So therefore I get dx over dt. So from this equation we have to determine the rate of change of distance between those two persons. That is basically we have to find this quantity dx by dt. So we will keep this on one side and transfer everything to the other side. So which means now we can see that we have the value of theta. So I can plug in the value of theta as minus sine of theta is given as 0.5 radians. So for theta I plug in 0.5, and we also know the value of d theta by dt, that is 0.01 radians per minute. So I can simply put 0.01 equals, and this is equal to minus 50 divided by x squared. The value of x is 50 divided by cos 0.5 quantity square times of dx by dt. Now let's simplify this little bit further. So this is equal to, we can divide both sides by negative 1, which means we can cancel this negatives, and then this becomes 0.01 sine of 0.5 equals, this side we have 50 on the numerator, and in the denominator we'll be having 50 square times of cos squared 0.5. This will get multiplied with numerator. So I can write down this as cos squared 0.5 times of dx by dt. This can further be simplified. I can cancel this 50 and 50 squared as 150. So this is basically 1 by 50, and then we can multiply by 50. So therefore this is equal to 50 times of 0.01 times of sine of 0.5 equals cos squared 0.5. So it's basically we can divide both sides by cos squared 0.5. So when you do that, I can divide it to the left side. So I can put this as cos squared 0.5. This is the value of dx by dt. So we just have to plug these values in the left side into the calculator to determine the value of dx by dt. And when we plug this into the calculator, we get the value of dx by dt equals 0.311. This is in terms of feet per minute. So basically the distance between the two persons is changing at a rate of 0.311 feet per minute. So this answers this question.